Alright, so number 55 says that there's a 10 kilogram block released from this point, point A, and it slides down a frictionless track, except for this part, but it slides down and hits a spring, compresses the spring 0.3 meters, and there's K is given, but we'll include that later when we plug stuff in. There's friction only in this 6 meter part of the track right here. And it asks you, what is the coefficient of kinetic friction when the block is traveling over this place right here? So to set this up, we're just going to use conservation of energy. So gravitational potential energy initial plus spring potential energy initial plus kinetic energy initial equals gravitational potential energy final plus spring potential energy final plus kinetic energy final. And you also have to add one more thing. Since you pass over the friction, if you add the work of friction here, this will show you where the energy here is lost. So since your height here is 0 at the final place, your final potential, gravitational potential energy is 0 because the height is 0. When the block stops on the spring, its velocity is 0, so your kinetic energy final is 0. Kinetic energy initial is also 0 because you're starting from rest, so velocity is 0. Spring initial potential energy is also 0 because delta, the x in the half kx squared, is 0. So what you end up with gravitational potential energy initial is spring potential energy final plus work of friction. Alright, so if you set up the equations, you get mgh equals half kx squared plus force times delta x for the work of friction. So if we just start plugging in, the mass is 10 kilograms, gravity is 9.8 meters per second squared, height is 3 meters initially, equals half, K is given, 2250 newtons per meter, x squared is 0.3 meters squared. Right. And so to find the work that friction does, we have force times delta x. Delta x we know is 6 meters because this is how long it's moving with the friction or against the friction. The force of friction we know is mu times normal, and since it's not moving in the y direction over here, we end up with mu kinetic, I guess, times mg. So overall, F delta x equals mu kinetic mg times 6 meters. So if we just put that over here, mu kinetic, 10 kilograms, 9.8 meters per second squared, 6 meters. When you work everything around, when you move everything around, you end up getting the coefficient of kinetic friction is 0.328. And that's it.